Hi everybody, welcome back to my playlist on physics textbooks. Today we're going to do the seventh in the version 2 on quantum field theory. In the last playlist, number 6, I sort of introduced some books that you should study on particle physics and Feynman diagrams and relativistic quantum mechanics in preparation for quantum field theory. The quantum field theory books, many of which I have, especially the older ones, will sort of review this, and I might repeat one or two of them. Quantum field theory is a very, very difficult subject. It's considered one of the hardest subjects in physics, and that's why a lot of people like myself own a lot of books on quantum field theory. We keep going from one to another, hoping to find the Holy Grail. There are a lot more quantum field theory books available today, and a lot of them are much better. So I'm going to proceed in basically chronological order. So some of the better books are at the end of the video. Anyway, I want to start by I have a course that I'm developing very slowly on quantum field theory. I'm currently working on version 2, and I'm on lesson 3.5, which I hope to get done one of these days, pretty soon. But I have a lot of resources on this site anyway. So I recommend you look at my Piazza site on quantum field theory. I answer a lot of questions and have a lot of discussion on things. Also on the site, I have like a link on the resources page, prerequisites for quantum field theory, something that I wrote, and just all the books that I think you should have mastered or have some acquaintance with before you start quantum field theory proper. I also have a long note on quantum field theory textbooks, which I'm gonna, here I'm making a video on it, but if you want to see a written version, written several years ago, of some of what I'm going to say, it's there. So I want to start out when I was at Caltech in 1984. We used, for the first quarter, we used relativistic quantum mechanics, which is still a great book if you want to see Feynman diagram calculations and cross-sections. It's not a quantum field theory book per se, because it starts with the propagator method, but if you need somewhere, it's an excellent book to learn the Dirac and Klein-Gordon equations and to do Feynman diagram calculations. So even though it's very old, and it was old when I used it at Caltech, it was in 84 and the book was published in 64. For historical reference, I can't recommend using this book to learn quantum field theory, but it does have some aspects on dispersion relations and renormalization from an old perspective, long chapters if you want to see what people struggled with to understand renormalization and to prove renormalization and to do like two-loop calculations in detail. This book does it. So it's still a decent book, but it's old, and I wouldn't recommend using it to learn quantum field theory nowadays. For the third quarter at Caltech, we used the book Field Theory, a Modern Primer. It was in its first edition back then. The second edition and the second printing are very, very good. I think here's a link to the second printing, I think. It's been republished. This book is an excellent supplement book for quantum field theory. It mainly covers QCD. It's at a little bit of an advanced level, but it has a pretty good discussion of the Lorentz groups and the Poincare groups and symmetry and everything. I'm trying to get to the table of contents here. First chapter on how to build an action functional is well worth reading. And then he goes through the phi-4 theory, perturbative expansion. He's added, in the second edition, he's added chapters on like gravity as a gauge theory, and finite temperature field theory, and he's added quite a bit on anomalies. So this is a very good book. It's a little bit more difficult than your average quantum field theory book, but it's nice. It's by Ramon, who's a wonderful physicist, and you might want to take a look at it. Another book that when I was at Caltech and I was struggling with quantum field theory, this book came out, was Ryder's book. And this is one of the easier books on quantum field theory. It uses functional methods, but it has a very good start. Well, they didn't have the table of contents even. Okay, it has a very good start on like classical non-abelian gauge theory. My lesson 3.5 is supposed to cover this, and the Lorentz group, and so on. So if you want an easier quantum field theory book to start, this, and I also left out of this video, Mandel and Shaw have a quantum field theory book that's sort of among the easier ones. The next quantum field theory book that I acquired is, this is a book that's different from others. It's Quantum Field Theory of Point Particles and Strings. It's not a great book to learn quantum field theory, but it's an excellent summary of quantum field theory. And it's sort of like a review of what you need to know to learn string theory. And the excellent thing about Hatfield's book is that he covers quantum field theory. He uses all three perspectives, the canonical approach, the functional approach, and it's the only book that I know of that uses the Schrodinger wave functional approach. There is actually a wave functional approach to quantum field theory. It's cumbersome, but he's the only one that I know that covers it. So this is a book that, if you want to review quantum field theory, might be very worthwhile. Another book that I bought, decided was too difficult, and sold, and then repurchased when it came out as a Dover edition, is this Quantum Field Theory by Zuber, and I guess that's its son. This is like a French-oriented type of physics book. The thing about it is that its level is a little bit above most first-year graduate students' level in terms of providing detail on calculations. Conceptually, there's no difficulty. If you look at the table of contents, it looks like a routine book. But what this book has is it has a lot of detailed calculations in small print. It doesn't have any problems in this book. It sort of works out the problems in the book. And it's got some excellent, like, two-loop calculations and everything that you just won't see anywhere else. I've seen them in Borkin and Drell. This one goes like beyond that. It's a reasonably modern book. It was written in about 1980. I think it was used for the Harvard course for a while. And it's just a little bit, some of it's out of date, like this current algebra stuff is probably out of date. But it's a little bit, it's hard to read because it's sometimes it's just written at a more advanced level than your usual quantum field theory book. Now the next set of books that I purchased, these are famous books. They're definitely difficult. I do not recommend starting with these books, but after you have some quantum field theory under your belt, Weinberg's books, volumes 1, 2, and 3, are an excellent set of books for explaining why quantum field theory has to be the way it is. And he sort of worked all this out. He's like the premier physicist of the last quarter of the 20th century, and he passed away a couple of years ago, and the first quarter of the 21st century. But he really sort of worked out in detail how and why quantum field theory is the way it is, and it's in his book. And it's a difficult read because it approaches the subject differently from all other QFT books, and it's got a lot of detail in there. But some of it, like Chapter 2 in Volume 1 on the representations of the Lorentz group and Poincare groups, is well worth reading. So this is the type of book, my goal is to be able to read all 2 or 3 of the books. I'm not really that much interested in supersymmetry unless it ever gets actually experimentally discovered. But the these books, volumes 1 and 2, you know, that's my goal, to sort of get through those books. Now, moving on, this is sort of the modern age of quantum field theory textbooks. And I would say to a student who's studying quantum field theory that they should probably look to own about 4 books on quantum field theory. And the 4 books that I would recommend are Peskin and Schroeder, An Introduction to Quantum Field Theory. This book was like the successor to Borkin and Drell. It's very calculational. It's very oriented, you know, toward getting people to do Feynman diagram calculations as soon as you can. But it and it has some excellent chapters on symmetries and renormalization and everything. My only criticism about this book is that it jumps around a little bit. Early on, it wants to get so quickly to Feynman diagrams that it skips things like, and it tells you that it's skipping things like photon propagators and various things, and then it comes back to them later halfway through the book, and you don't even remember that you cheated like 4 times. It tells you, we cheated 4 times, and now we're going to remedy that. So I'm not that thrilled with that approach. But this has been the standard textbook in quantum field theory. It's a, it has excellent problems, and it even has published, I think, on the archives, there is a, I don't know why this link isn't coming up. Anyway, on the archives, I don't know why that didn't come up. Okay, here it is. It was published, A Complete Solution to Problems in Quantum Field Theory by Peskin and Schroeder. So I don't recommend looking at these solutions. I recommend working out the problems yourself. I worked out the problems in the first probably 60% of the book and was able to do almost all of them. And you'll learn a lot from the problems, but I guess if you get stuck, you can look at these solutions. So Peskin and Schroeder is one of the 4 core books I would recommend that you own on quantum field theory. The second core book is Quantum Field Theory in a Nutshell by Anthony Z. This is like a diametrically opposite book. This is the best concept book on quantum field theory. He does only one really detailed calculation in the book. He says so on the anomalous magnetic moment of the electron in quantum electrodynamics. But it covers some really advanced stuff conceptually. And he even has things like new developments on amplitudes and everything. Came out with a quick second edition. And he added all this stuff on amplitudes and supersymmetry and cosmological constant. He does gluon scattering and a lot of these new topics. But it's all conceptually. The details aren't here. You'll need another book for a lot of the details. But it will help you understand quantum field theory. It should be used as a supplement to any quantum field theory book you have. The third core book that I recommend you own was my favorite quantum field theory book. It was by Mark Srednicki. And there's 2 good things. There's a lot of good things about this book. One of them is that you can get it online. It's an authorized draft, which is basically complete. That's online at this link, and all the errata are there. And it's just an excellent book. I wrote a review on it. It does things in a very pedological way. For one thing, it has 3 parts. It starts with scalar fields, and then goes to spinor fields, and then goes to gauge fields. So you start off, you avoid all the indices and all the complexities of Ghost and Grassmann variables and gauge fields with the scalar field theory, which is the first part of the book. He does phi cubed, which is different. Most books do phi fourth. Phi cubed is a pedologically very interesting theory in that a lot of the stuff that doesn't show up until second loop in most quantum field theories like phi 4 shows up in phi cubed. Phi cubed is not a physical theory because it's not bounded below, and it's in 6 dimensions that it's renormalizable, I believe. But it's still, you'll learn how to do quantum field theory, any quantum field theory, in any number of dimensions from this book. Some people say this book is difficult. I don't know why. I think if you're prepared for quantum field theory, you'll have no problem with the book. He's got short chapters, which I really like. The problems are all doable. I did them all in the first half of the book very easily. They're not trivial problems, but they're not research problems, and they really let you understand quantum field theory. So this is the third core book that I would recommend. And then finally, the fourth core book. This may be my favorite quantum field theory right now. It's Quantum Field Theory Lectures of Sidney Coleman. Sidney Coleman taught the quantum field theory course at Harvard for a long time. He even made video lectures, which are online, and I'll show the link there as well. The problem is the quality of them has deteriorated. It was on videotape. But this book is like the Feynman lectures on physics for quantum field theory. They're lecture books. It's not out of date. It sort of goes up to 1990. It was put together by his students from his lectures, and it really covers the subject well from using lectures. Very easy to understand, and the best thing about this book is that it has 25 problem sets that we used at Harvard with solutions. So if you want to see some really good problem sets and solutions, I didn't get the table of contents there. That's what I wanted. This is the book. So I highly recommend Coleman's book nowadays. Is maybe the best place to start learning quantum field theory, just because it's lectures. Okay. And these lectures are available on YouTube. Here they are. As you can see the quality is not going to be that great. Coleman is a very interesting lecturer. He's sort of like a cross between Woody Allen and Albert Einstein. He has the genius of an Einstein. Coleman was called a physicist by no less than Steven Weinberg. And but he's also like Woody Allen in that he tells jokes and everything. And the great thing about some of these lectures is he smokes in them. You can see how times have changed, but he's constantly lighting up a cigarette and smoking. So these are also available on the Harvard site. I think this is the Harvard site with all the lectures. There's like 54 of them. So for those who like to watch lectures, there are many lectures on quantum field theory online by people like David Tong and lots of people. There are many great lecture notes online, like by John Preskill at Caltech, but I'm just covering mostly the books. Now, this book I've only looked at briefly. This is like the latest major quantum field theory book published. It's by Matthew Schwartz. It gets excellent reviews. It seems to be like the most complete book to really, not just quantum field theory, but the standard model. I think it's quite long. Sorry about that. Well, I wish they would give at least a table of content. Here it is. Sometimes they cut these short. But he has a lot of coverage of the standard model up to very recent LHC type of physics, heavy quark physics, background fields, jets, and effective field theory. So I was wrong. It's only about 800 pages. It's not that long a book. The only criticism of this book that I've heard is that he's a little bit lax with his indices. Sometimes he puts them up, sometimes he puts them down. He's not that concerned about having the indices in the right place. Then another very recent book that was published this year or a year ago is Quantum Field Theory by Eduardo Franken. This is an integrated approach for those who are looking for a condensed matter field theory approach. or at least to have that alongside of the traditional elementary particle high energy physics approach. I guess he does that. I have not actually looked at this book, but it's something you might want to look at. Yeah, boy. I'm very sorry. Okay. Also, another condensed matter book that I highly recommend that covers is oriented condensed matter field theory. This is a wonderful book to read. My main interests aren't in condensed matter field theory. I should have a playlist on it, but I don't. I don't have that many books on condensed matter field theory. But this is a book which has a lot of orientation toward condensed matter physics. If you have some quantum field theory, you'll find it a relatively easy read. And he's got biographies of all the people who have made contributions to condensed matter field theory. He has good chapters on topology and various things. So another book, this is an extremely difficult book. It's an online textbook. It's Fields. It's probably, I have version 3, but I think version 4 is basically almost out. And you can get it online and download it. It's like 1,500 pages. It's a thoroughly modern perspective on quantum field theory aimed at getting you into like string theory as fast as possible. To me, it's like impossibly difficult, much more difficult than Weinberg. Maybe that just says something about me, but it really something to look at, and it's free and it's online. And if you want to read about all the major new developments in quantum field theory and applications to string theory, here's your book. 2 old books that I used at Caltech or were recommended to us was a Methods in Field Theory book on LeHouchez. I don't think it's available online right now. This is like a table of contents, I believe, is all I'm going to get here. Let's see. You can see, this is in French, so it might not be that useful. Well, they have French and English. I want to see if they have the table of contents. Here's the table of contents. You can look at this. This was published in 1975, but it has a lot of like the developments, functional methods, renormalization theory, sort of like how gauge theory is, how quantum field theory developed. In the 70s, it really came into its own, and that's what this book is covering. And it has things on gravity by Veldman and everything. Again, this might not be that relevant nowadays, critical group, critical phenomena. But I thought it was a pretty good read. And how to get it nowadays, I don't know. On Amazon, it says it's not available. But I guess you look online, somewhere you'll find it. The other book is available still, and this is again by Sidney Coleman. It's called Aspects of Symmetry. He would go and give lectures in Italy like every year, every summer. And so some of these are like very old lectures and, not that relevant. But still, you could get things like unitary symmetry and the quark model. You can learn some old stuff pretty easily, pions and all that stuff. And then he's got things on like renormalization, instantons, classical lumps, solitons, and everything. So this is a pretty good book to learn some of the advanced topics in quantum field theory, 1/n expansion, and everything. So it's by Sidney Coleman. It's well worth reading. So I usually don't put up books. There are a couple of books that are meant for advanced graduates in quantum field theory. I bought this book a couple of months ago just to see if it was as good as people say it was. And I have to say I thought this book was horrible. It was harder to read this book, in my opinion, than a regular quantum field theory book. And half the time they would do about half the calculation and then they would like bail out and say, see Peskin and Schroeder for the rest, or see Srednicki for the rest. And it has a lot of you have to be like a condensed matter field theory expert to really understand this book. But like I said, instead of being easier than Peskin and Schroeder or Srednicki, I thought it was harder. So I do not recommend this book. It has a nice title, and a lot of people say they love it, but I really wonder how many of them understand it. Another book here, Student-Friendly Quantum Field Theory. This is a different approach to quantum field theory, and it's definitely probably the easiest book for a advanced undergraduate or a beginning graduate student to read. Rather than give a complete review of this is not my cup of tea, but there's a website with this book, and at least in the volume 1, half the chapters are available. You can download them and read them like every other chapter. So here you can take a look, you know, like here's chapter 1, you know, and I just don't like, he's very big with charts like this, you know. And to me, I found them more confusing than helpful. Some people love these things. I just wasn't into them. So this is just a matter of you can sample it yourself and see if it's worthwhile. He's extended this. It used to cover only like the basics, but now he's got a volume 2 out, which covers volume 2. I think goes deeper into well, I'm trying to think of what the name is of volume 2. He seems to go deeper into, let me see on the contents, the standard model and everything. He didn't have that, and path integrals, and he's got various things that he wants to eventually add and cover, bring it more up to date. Volume 1 was just very basic stuff. So I would say download some chapters. You know, he's got a chapter on group theory I think you can access. So you can see, again, if this is worthwhile to you, if it is, if it isn't. Like I said, I didn't care for it, not because it was too elementary and everything. I just thought it was too confusing. Now, maybe for somebody else, they think this way with charts and so on. So that ends this video, and next video I will come back and do stuff on the string theory, standard model, you know, advanced stuff beyond quantum field theory. I'll see you next time. Thank you for watching.